Hello everybody. This video is going to be looking at properties of angles in a circle. So let's start off with a couple definitions here. The first one you're going to need to know is what's an inscribed angle? Well, an inscribed angle is made from points sitting on the circle's circumference. Okay, so you have point 1, point 2, point 3, and this creates an angle. This is called an inscribed angle. Okay, so basically it just has the vertex, which of course is this point on the angle here, that sits on the circle. Okay, A and C are referred to as endpoints. And the next thing we'll talk about here is kind of a rule with inscribed angles. So if A was an inscribed angle, what we have here is called a central angle because it has the vertex at the center of the circle. Okay, so this is called a central angle. This is called an inscribed angle. And what you see here is that they share something. And they share this little arc here. And when they do that, that's called being, the angles being subtended by this arc. Okay, so basically they share the same endpoints. And this creates a relationship between these two angles in that the inscribed angle is half the size of the central angle. Okay, so if this was 50 degrees here, an angle A, the central angle, being that they are subtended to each other, they share the same endpoints, it will be double, so it will be 100 degrees. Okay, and we'll get into some more examples with that. Okay, so angle A, also when we're looking at inscribed angles, you can see that these two angles here, A and A, are subtended again by this arc. Okay, so they share the same endpoints. If this was a point A and this was a point B, they share a point A and B, this arc in between. Okay, which means if they share the same endpoints and the angle is inscribed, so it's sitting on the edge of the circle here, that means that the inscribed angles are the same measurement. Okay, this is kind of a theorem in circle geometry. Okay, so the angle, this arc, this highlights the subtended portion of the circle here that shares angle A, and which is an inscribed angle, and 2A here, which is the central angle. Okay, so we know that if this is 25 degrees on the inscribed angle, the central angle is in fact 50 degrees. Okay, over here it can appear like this as well. So if we get 2A here, again, they're sharing the same. Okay, this one is inscribed, this one is central, so this would be half. If this was 50 degrees, this would be 100 degrees. Okay, so let's look at a couple examples here. So you're given an angle here of the central angle and the unknown inscribed angle represented by D. We know that the central angle is double this, so what do we do to solve the inscribed angle? Well, we just chop it in half. So 80 divided by 2 is going to give us 40 degrees. We know the inscribed angle here is 40 degrees. Over here, same thing. We're given the inscribed angle and asked to find the central angle here. Okay, we do realize that they are sharing this arc, so the angles are subtended, which means that this is going to be half of this. So if we double it, we times it by 2, we're going to get 144 degrees for that one. Okay, so moving on now to the second theorem I want to talk about, which is the when angles are subtended by a semicircle. Okay, so if they are subtended by a semicircle, so what do I mean by that? Well, I got two angles here, okay, and if you notice that their endpoints in this point and this point, okay, which you can see is the same for this angle, this point and this point, so they're sharing this semicircle here, okay, the diameter like goes across here. So in that case, when the angles are subtended here, each one of these is going to be equal to 90 degrees, okay, because the endpoint lie on a semicircle. Okay, so half the circle here. And we'll look at more examples in this slide. Sorry, not that slide. We will come back to that. it actually. Actually, no, let's go do it now. Nope, let's go back. Sorry, guys. Okay, so what we have here is a triangle inside, and basically we need to realize that, yeah, sorry, this is a subtended by a semicircle, my bad. So here we go, we got our semicircle here, and we know that if the endpoints lie on the semicircle here, they're subtended by that semicircle, it's going to be 90 degrees. Okay, so one of the angles is 90 degrees, so it's going to be this angle is 90 degrees. So even though we're given two unknowns, we know that because the endpoints lie on the semicircle here, it's subtended, that's going to be 90 degrees. And we know that the sum of all three angles in a triangle needs to be 180 degrees. So in order to solve this unknown here, we just say 180 minus 90 minus 70, and that's going to give us angle A, which is 20 degrees. Okay. Same thing in this picture. We see that the angles are this angle is subtended by the endpoints here on the semicircle. So we know that this is 90 degrees, this is 45, so we know that all the angles must add up to 180, so we start our equation by saying 180 subtract 90 subtract 45, and we'll be left with 45 degrees. So just to sum it up here in these diagrams, again, the angle subtended in a semicircle is a right angle, meaning here is my vertexes here, and they share common endpoints right on the semicircle. Therefore, they're going to be 90 degrees. And remember this guy here, the angle subtended by an arc at the center of a circle is twice that at the circumference, so that all that's saying is that my inscribed is going to be half of my central angle because they share common endpoints here. It's subtended by this arc. Okay, let's look at a couple examples here. I'll call this example 1. We know that, well, we can see from this picture that it is subtended by a semicircle, and so all we have to do here is realize that our three angles add up to 180, so we'll just say 180 subtract 90 subtract 70, and that's going to give us an answer of 20 degrees. Okay. Over here, again, we see it's subtended by a semicircle, so we know that this angle right up on the top here is going to be 90 degrees. So we just say 180 minus 90 minus 45, and we're going to get a 45 degree angle measurement there. Okay. This one here, we just do some simple math. We know a straight line is 180 degrees. If the outside of this is 130, we know that the inside here must be 50. Okay. We know this is 50 and this is 90. So to solve angle C, we just say 180 minus 90 minus 50, and that gives us an answer of 40 degrees. Okay. These guys down here, we know that the inscribed angle is half that of the central angle, so we just divide it by 2, so angle D would be 40. And opposite here, we just are going to multiply our inscribed angle by 2 to get our central angle measurement, which is going to be 144 degrees. Okay. And this one here is essentially the same as this guy over here. We're given our central angle, and don't be confused because it's sitting to the right and not behind. They share common endpoints here, which make up the angle. So that is a subtended arc, so we realize that the inscribed angle is going to be half that of the central angle. So all we do in this case is take our 78 and cut it in half, and we get a measurement of 39 degrees. And that's it for this video, guys. If you need any more help, please don't hesitate to come ask me. Cheers.